Yeah, let's start off. Camps on everyone. Let's start with this. Diffraction. Single slit experiment. Hmm. Interesting. Today we have a lot more people because it's at 10% weightage. I should have given mentioned weightage for each and every topic, I guess. More people would have come. And some people are so great they don't even know the timings of the class. People are messaging what time is the class. Chal, let's get this. None of you still got the timings, na? They didn't tell you the center and the time, right? Only sirf the day you come. I think you will get it 4-5 days before the exam, I guess. Anyways, I think let's get this. I hope you guys remember the formulas. In case you forgot, you will remember today. And make sure to revise this stuff. Others, if you don't keep your cams on, you'll be removed from the classroom. So yeah, I just kicked out 6 people. Let's see. Now, in case you forgot the formulas here for diffraction, so when we have a single slit here, you send parallel beam of light. So the parallel beam of light won't get focused automatically. So we have to actually use a lens. So this parallel beam of light will fall on the lens and then they converge. So this would be the capital D, which is also equal to the focal length. So remember that. Sometimes they won't give you the distance of the screen. They will give you the focal length of the lens in the second question. So focal length of the lens is the capital D. So D is equal to the focal length. And hope you remember how the pattern forms. You get a central maxima and then you get small minimas actually. This maxima here. The width of the central maxima is 2 times lambda capital D by small a, where small a is the width of the slit. And lambda must be almost equal to a for diffraction. So this position here is your first minima. And the remaining fringes will be lambda d by small a. They will be of equal width, only the central fringe is the biggest. And where does the minima occur? Sine theta is equal to n lambda by a. This is the condition for minimus. That's your main thing there. There's also something called Fresnel distance. Yeah, z square by d square by lambda. So you should know that. Check it out in case you don't remember. So this is your minima ka position. That sine theta is equal to n lambda by a. And the intensities are this thing, what you call, they're not equal. And then there are even more points. If you see in diffraction total, there are like 6 or 7 points there. Lambda is equal to a for better diffraction. Second thing, central fringe is 2 lambda d by a. Third, sine theta is equal to n lambda by a for minima, n is equal to 1 for first minima. Third, the phase difference between the two light rays from the two corners is 2 pi. That is the fourth one. Fifth one, if you make the slit ka size double, then what will happen? Intensity of the central fringe will become 4 times. वो भी एक था. And the last thing, Fresnel distance. Fresnel distance is the distance after which the diffraction becomes dominant. So if you want to operate a microscope or a telescope, you have to make sure microscope, the instrument distance must be less than Fresnel distance, d square by lambda. So how do we solve this thing? These are all the formulas there. You should check it out. So for the first question, in a single slit diffraction pattern, the distance between the first and the third minima. So first and the third minima, that is basically two fringe, meaning if you have to draw the picture, this is how it would look. This is your central maxima. This, and this. So this is your first minima, and this is your third minima. First, second, and this is the third minima. This is your second minima. That means you are asking to find the distance of 2 lambda d by small a. Bas substitute kar lena directly. That's it. The questions are easy. You should know the formulas and what is happening there. Lambda will be 6000 angstroms, 10 power minus 3. Capital D is 50 centimeter, that is 0.5. And you want to find A, and he's saying this is 3 mm, which is 3 into 10 power minus 3. Solve this thing. So 2.5 will go off. A, that would be 3, 2. That is 2, 1, 2, 2 will go off. I think that will be 2 into 10 power minus 4 meters, I guess. Check out your answer. I'll leave the calculation to you. Clear with this? What about the second thing? Same story. The diffraction pattern of a light of wavelength 400 nanometers. So lambda is given 400 nano 10 power minus 9. Slit ka width is given 0.2. Focal length f is given 100, which is actually capital D. So question is not tough. But when people see the focal length, they don't understand what to do. They'll think like, what is capital D here? So you should know in the experiment, they actually use a lens to focus the light rays. And he's asking the width of the secondary maxima. So the width of the first secondary maxima. So be careful. Central maxima is 2 times the length, whereas this thing is only lambda d by capital D. Substitute, you'll get the answer. Clear? Next one. Get this. This is not exactly instruments, but this is one important thing we missed out last time. Combination of self-inductances with mutual inductance. Unlike resistors and capacitors, right? Inductors are a little weird. Depends on your orientation also. So what will be the equivalent self-inductance for this? So here you just have to look at the directions here. So in this, the current is flowing this way. So the field is this way. Here the current is going this way. So this field is also this way, and both are opposing each other. Therefore, L equivalent will be, the fluxes will oppose L1 plus L2 minus 2M, the D option. So you just have to look at the orientation. Are the two fields inside are opposite or equal? If they're equal in the same direction, that means the fluxes of each other are supporting each other. Clear with this? That way. So in case, if I want to write the equation, you should check out the notes. We really have a very good discussion there. So the flux in the first loop will be L1 into I plus M into I2. That is the flux in the first coil. So L1, I1 is the flux due to your own self-inductance. M into I2 is the flux due to the other guy. Because here it is in series, I1 becomes equal to I2. Are you clear with this? Now, if the flux is not supporting, then it can become minus also. So that is where you get the minus sign from. Clear? So unlike capacitors and resistors, right, inductors can interfere with each other. So if this question had been like this, then it would have been L1 plus L2 plus 2N. So be careful with the orientation there. The flux in the secondary coil would have been L2, I2 plus or minus MI1. Let's get this thing. dispersion and this thing deviation. We have a thin prism of angle 6 degrees. Refractive index of yellow light is 1.5. Is combined with another prism of 5 degrees. Refractive index of yellow light is 1.55. The combination produces no dispersion. The net average deviation produced by this combination is how much? All these are mains ka questions. You guys might think I picked out from some random place. That's the reason I picked out from all PYQs. These are actually which came in the JEE mains exam. If you're wondering, oh, it is like that, that means you guys didn't even bother to solve your PYQs properly. You must have done all the other chapters, and when these chapters came, you must have just rushed them, or you didn't put enough time. Now, in case you forgot the result, remember for prism, there are two things here. When you take a prism A and when you send a white light, I'm using a black line for that. The colors will split. Yellow, then you get some yellow in the middle, then you get something like a red and all. So this is a deviation of red and this is a deviation of yellow. This angle between them is called dispersive angle. Which is deviation of violet minus deviation of red. And how to get the deviation here? Deviation is nothing but angle of the prism into refractive index mu r minus 1. This is for thin prisms. Delta is equal to A into mu minus 1. Hope you remember that. This will be A into mu violet minus 1. So this formula becomes A into mu violet minus mu red. This is your dispersive angle. Then we define something called omega, which is your dispersive power, which is nothing but the dispersive angle by the average deviation. That would be A into mu violet minus mu r. Generally, we take yellow here, which is mu yellow minus 1. If yellow is not available, we can also take mu violet plus mu red by 2 average. That's your dispersive power ka formula. Mu violet minus mu red by mu average minus 1. Average or yellow, any one of them. This is your dispersive power. And the deviation ka formula is A into mu minus 1. Those are the formulas there which you need. Now in this question, he is simply saying the dispersion is fine. Average deviation is what? So here the deviation will be delta plus delta dash. That's your deviation. You just add up the deviations of both the prisms. And be careful, if your prism is upward, A is positive. If your prism is inverted, then A is negative. So for the first one, the prism ka angle is 6 degrees into mu minus 1, that is 1.5 minus 1 plus minus 5 degrees, 1.55 minus 1. That is 3 degrees minus 2.75 degrees, which is 0.25 degrees or 1 by 4 degrees. X is equal to 4. How tough was the question? Just the deviation. But the moment you see this question, you will blank out. You're like, what the hell is being asked? That's it. You just have to get both the deviations and finish it off. If the prism up, it is positive. Prism down, it is negative. Clear with this? Polarization. Hope you guys remember that Malus law. Polarization, there are only two concepts, the Malus law and Brewster law. Brewster law and the Brewster angle. An unpolarized light beam of intensity 2I0 is passed through a Polaroid. So in case you remember, if you have a Polaroid and if you send an unpolarized light, what is unpolarized light? The light has electric field in multiple directions. If this intensity is I, when it passes through this, it will come out along the axis and the intensity becomes half. So whenever you send an unpolarized light through a polarizer, it will always become half. After this, if you try to send it through anything, let's say this is your axis, making an angle theta. And now if you send a polarized light of intensity height, then you get intensity like this, which is I cos square theta. So every time you pass through this thing, but polarized light, whenever it goes through a polarizer, it becomes a cos square theta. So now coming to the question here, you send an unpolarized beam of intensity to Y naught through a Polaroid, then another Polaroid in such a way that its passing axis makes an angle of 30 degrees relative to that of P. So it's a double polarizer. So we have one polarizer, we have one polarizer. So let's assume this is the axis of this polarizer. And he's saying it is making an angle 30 degrees relative to the P. So this is your 30 degrees. So you're sending an unpolarized light to Y naught. When it comes out here, the intensity becomes half. Then when it comes out here, it will become like this, which is I naught cos square 30. Cos 30 is root 3I by 2, 3I naught by 4. Clear? Let's get these two EM waves. An electric bulb is rated at 200 watts. Don't worry about this H. H is actually, that was removed in the portion, but it is simply the magnetic field by mu naught. That is called H, magnetic intensity. You don't need to know that for solving this, but let's see. So what is the first thing to do? In case you forgot, this is the formula for this. If you have a bulb B, power P at a distance R, the intensity will be power by cross-sectional area, which is P by 4 pi R square. Now in EM waves, we have studied the intensity is nothing but half epsilon E naught square, the peak value, into speed of light, or 1 by 2 mu naught B naught square C. So since light is an electromagnetic wave, it actually creates an electric and magnetic field in the region where E naught and B naught are the peak values. C is the speed of light, I is the intensity. And B naught is your peak magnetic field. There. This is the formula you have to use for the first one, and then you will get it. And for this thing, we know E cross B must be giving you the propagation of the direction of the wave. And there's also a name for this. If you put 1 by mu naught into E cross B, this is also called as Poynting vector, which is actually nothing but intensity. And we also know the electric field by magnetic field must be equal to speed of light. So using these two, you can figure it out. The first part now you can do. I will leave it to you. You can just substitute the values there and you will get the answer there. But this guy, if you look at this, now there are two components here. Huh? Sine kz minus omega t, sine kz minus omega t. E and B will be in phase. E and B are in phase. Matlab, if these are sine, they also must be in sine. Unfortunately, everything is in sine, so I can't eliminate anything with this. Great. Next thing, look at the first guy. For the first guy, this is AX minus. So E cross B must be the direction of the wave. Kz minus omega t must be k cap, isn't it? The Z implies here the wave is going in Z direction. So I'll do one thing, I'll write it down. So minus 301.6 sine kz minus omega t, that is I cap. So this implies wave is traveling in, wave is moving along k cap. And your electric field is minus I cap. So we need to figure out the magnetic field. So E cross B must be k cap. So this is minus I cap cross B is equal to k cap. So B bar must be minus j cap. So find an equation which has a minus j cap in this. So this guy is gone, this guy is gone, this guy is there, this guy is there. Similarly, when you do for this guy, this is j cap. J cross B bar must be minus k cap. So that also must be minus there. So this is also coming minus. Yeah, then we are stuck. Then we have to use the other relation, E by B is equal to C. But he's asking for H, so B H is equal to B by mu naught. So they're little working there. You'll be stuck between C and D. C is the answer. You can put the numbers and check it out. Now this magnetic intensity, right, it is removed from the portion. So mostly they'll ask you to find B only directly. So you can find for each component separately. Clear what to do? So you have only two relations there. E cross B must be direction of the wave. E by B must be equal to C. These two things will give you the result for most of the time. Let's get the same question. This time with numbers. So was 1B. I don't remember. I don't remember the answer for that. Check it out. Online में मिल जाएगा. Yeah, magnetization is removed. Get the same thing. Intensity of the light bulb is there, 0.22. So I is directly given. So I is equal to 1 by 2 mu naught B naught square C. You will get this thing. I'll leave it to you. You can handle this now. Let's get this thing. So how do you handle this? A beam of light is traveling, the ratio of electric force to the magnetic force. I hope you guys remember the Lorentz force, which is QV cross B plus QE. This is your Lorentz force. So here indirectly, what they're asking, he gave the EY. So E by B is equal to C. From there you got B ka value, which is E by C. So F electric will be QE. F magnetic will be QE cross B. V is given. Yeah, you know everything. So E is given. So E is 900 by C. And then I think you dump it, you'll get the answer. Right? You can check the answer there. I don't think it will be 1:1, but I don't know. 3 into 10 power 7 is also there. That's a good number. So ratio में तो indirectly it is E is to VB. E will be 900 by C, which is 3 into 10 power 8. B is also E by C. This is 3 into 10 power 7. E, I see. So E will cancel. C will. What am I finding here? Hmm. This is 3 into 10 power 8. Perfect. 900 goes off. I got 10:1. Clear. So it actually depends on the speed. Huh? They won't be equal or something. Semiconductors. So what is dynamic resistance? Normally resistance is V by R. Our dynamic resistance is nothing but dV by di. Small change in current by this thing. Basically slope in a VI graph. But here you can't find the slope, so you just literally have to do delta V by delta I. So how do we handle this? So for the first one, you can clearly see between these 2 points, delta V is 2.1 minus 1 by delta I is 10 minus 5. That's 0.1 by 5. That's for R. Now for the second region, take between these 2 points, let's call it R2. Be careful, voltage is on x-axis, current is on the y-axis. R2 will be 4.24 by current will be 250 minus 200. 0.2 by 50. Divide them, you'll get the ratio. I think C is the answer. C or B? B. 5:1. That's 2.1 minus 2, yes. Clear this? So again, not a tough question. They'll ask you dynamic resistance, PN junction. You will just hear these words and you'll get scared. PN junction, forward bias, dynamic resistance, gone. Your fuse blows off there only. After that, you won't even bother to read the equation. After the exam, you'll see this and then you'll cry. You lost unnecessarily 4 marks. Logic gets. So this is A, this is B, and this is output. This is representing which gate? The picture is weird. You need to understand how to think about it. Think for a minute, then I'll show you. The example picture will look like this only. You need to figure out what they're giving actually. So what is the catch in this? Take this as a reference line. Okay, so when the graph is like this implies this is 1 on, this is off 0. So if I give extended like this, that means this is, you can split into equal. So this is 1, this is 1, this is 0. That is how you read them. Basically, there are ones and zeros. So now if you try to read this, so this is 1, 0, 0, 1, 1, 0, 0, 1. Here it is 1, 0, 1, 0, 1, 0, 1, 0. Output is 0, 1, 1, 1. So I think with this 4, you can figure it out actually. Look at this. When it is 1 and 1, you're getting a 0. So A, B, output 1, 1 gave you 0. 0, 0 gave you 1. 0, 1 also gave you 1. 0, 0 also gave you 1. This thing clearly looks like a NOR gate, isn't it? This is OR ka opposite. So B option, right? No. That's a NOR gate or NAND gate. Sorry, this looks like a NAND gate. That's your B option. Make sense? This output here is A dot B ka bar. Clear with this? So this is how they'll give. Every time they won't just give a circuit. So you can check it out. That is the meaning of those lines. You know, the up and down jumping are ones and zeros. All this, I'm sure if you have solved, you would have seen this. We have done some of them in the class also. Zener diode. I'm just reminding you in case you forgot. Definitely at least 2 questions that you will get from whatever you're reading today. Matlab, not the exact same thing, but the models we are trying to cover. And it is specifically written in the portion also, 10% weightage for all these main SCA topics. This is like your inorganic physics. So what does a Zener diode do? A Zener diode will always maintain a constant voltage under the assumption if the voltage is greater than breakdown voltage. So be careful with that. If the voltage is less than breakdown, a Zener diode will do nothing. It will just act like an open circuit. So first you need to always check whether you have enough voltage. This is the symbol for Zener diode. In Zener diode, what kind of breakdown happens? In Zener diode, what kind of breakdown happens? There are how many kinds of breakdowns and what happens in each breakdown? You can just answer it to yourself. So Zener diode will act like a voltage regulator. What kind of breakdown happens here? Zener breakdown happens here. What is a Zener breakdown? This happens when the crystal is highly doped. When it is highly doped, then what happens? The band gap, okay, forbidden gap, width is proportional to 1 by doping concentration. Doping meaning introducing impurities. If you introduce a lot of impurities, you have a lot of charge carriers. So because of the forbidden gap will be very thin. So we get a thin forbidden gap. Now because of the thin gap, the electric field will be V by D. We will get a high electric field. Because of high electric field, there will be a dielectric breakdown. So the region which was an insulator suddenly becomes conducting. This breakdown is called Zener breakdown. The other breakdown is your avalanche breakdown. What is avalanche breakdown? This happens when there is a low doping. When you have low doping, the gap becomes bigger. When the gap becomes bigger, you're letting the charge carriers, you're giving them enough space, to move faster and faster. So these minority charge carriers will become forward bias and they'll go so fast, they'll start hitting every other bond and the bonds get broken. Literally, the whole circuit burns down. This is irreversible. The avalanche breakdown is a nuisance. Zener breakdown we can actually use it. So you should know what happens like Zener breakdown. And in case if you remember the graph for the current versus voltage, the forward bias will not work up to a critical voltage. It will be 0.7 for silicon, 0.3 for germanium. Most people think forward bias will immediately act like a wire. No, it will take some time. It will need some voltage. Then it goes up. This is your forward bias. In the reverse bias, there will be no current for some point and then it breaks down. This is your breakdown voltage. So even if you put a Zener diode, but if you don't give enough voltage, it will act like a reverse bias only. Only after it exceeds breakdown, current will start flowing. So keep that in mind. So that's a bit about it. So how do we solve this? He said there are two situations, ratio of maximum and the minimum RL. Now, if you see the word here, the maximum Zener current is 10 milliampere. That means you can also have zero current. So draw two circuits. So in the first case, you take current here is 0. But remember, this will still have 8 volts. If this is 8 volts, this is 2 volts. Then this current will be 2 by 100, 20 milliampere. That means all the current should pass through this 20 milliampere. But remember, this voltage is always 8 because the Zener diode will maintain the voltage. So R1 will be 8 by 20. In the second scenario, this current will be 20 milliampere. Now Zener diode can take maximum current, so 10 milliampere. That means here the current is 10 milliampere. The voltage is still 8 volts. So now the resistance R2 will be 8 by 10. And divide R1 by R2, you'll get the answer. Or R2 by R1, whatever they're asking. I think R1 by R2 only. Clear with this? There is a catch in this kind of questions. So a Zener diode will maintain a constant voltage. It can take any amount of current, but will maintain the voltage. So the 2 volt is getting 20 milliampere. So Zener will take 10. Remaining current has to go through RL. And because both are in parallel, the voltage will maintain 8. So I know the current, I know the voltage. Get the resistance. Clear with the question? Moving coil galvanometer. You should know the experiment there. Moving coil galvanometric experiment. Now, in case you forgot the experiment, listen. This might be also there for your HSC boards. Now, remember the experiment, the top view, you will have two magnets like this. North pole, south pole. And the reason, if you see these magnets, right, are manufactured like this because the field lines will be always perpendicular. That is the purpose of cutting the magnets like this. This will generate radial magnetic field. So the advantage of this thing is when you take that cylinder, no matter which way the coil rotates, this green thing is your coil. This would be your area vector. The magnetic field which is passing like this, it will be always like this. So B bar is perpendicular to A bar for all angles for every time. Because the moment it rotates, then you'll take another magnetic field. So the field lines will be always parallel to the coil at all positions. This is an important thing. And if you actually look at the side view of the picture, it looks like this. We have a cylinder. Here you connected with a spring. Here it is connected with a spring. These are your torsional constants K. And here you have your magnet. Something like this. The north and the south magnet. And your coil is like this. This green thing is your coil. Then the torque will be mu cross B. Right? This is your magnetic torque. And there is also torque due to the torsional torque. So when you're twisting the spring will also generate a torsional torque, which is K theta. K is your torsional constant. In equilibrium, both will be equal, and mu B will be NIA B. Theta is 90. So we get NIAB is equal to K theta. That's your formula there. So here, put theta by I. This is your angle per unit thing, which is a NAB by K. This is called current sensitivity. Getting it? This NAB by I. This is your current sensitivity. I by theta, if you write it in the reverse, this is also called as figure of merit. So that's your angle deflected per unit current is your sensitivity. So there, that's the formula which you actually have to use. Easy to derive. Actually, if you remember the process, you can derive this. They gave you everything you need here actually. You just substitute the formula and you're done. Deflection in the coil, theta is given, current is given, torsional constant K is given, magnetic field is given, area is given, the number of turns are given. He is asking you for area. I know N, I, B, K, theta, done. Substitute, you'll get the answer. Clear with this. So I don't know the answer, but I think people got B. So there. But is the experiment clear, everyone? Now, in this experiment, if you remember, there's one more important thing: voltage sensitivity and current sensitivity. Theta by I is current sensitivity. And you can clearly see this is NAB by K. Even I don't remember the formula. I'll derive this every time actually. And if you see, if you increase the number of turns, the sensitivity increases. N increases, sensitivity increases. What is sensitivity? Higher the sensitivity, you can measure smaller and smaller currents. But if you do theta by IR, that is if you do NAB by K into R, this becomes theta by V. This is voltage sensitivity. So the voltage sensitivity here, if you see N by R, AB by K, the catch is this. The resistance will be rho length by area, and the length here is number of turns into perimeter. So NN will get cancelled. This actually becomes constant. So voltage sensitivity is independent of number of turns. More than this formula, remember this. Later on, I'm going to ask you something where this won't work. But standard question is this. If the question is only this, if the number of turns are changed, what happens to the current sensitivity and voltage sensitivity? So basically, when you increase the number of turns, the distance also increases, that N by R will remain constant. So you should check out the notes. This is the moving coil galvanometer in magnetism. Get them. These are 5 questions. Just get the main formulas, that should do. One more thing, I'll forget again. I'll just put it down. Do you guys remember this thing, half deflection method? Half deflection method. What is this? This is an experiment to find the resistance of galvanometer. So how does this experiment work? We have done this in current electricity. Experiments also we did. So this is the concept there. First you take a galvanometer, put it to a battery. Voltage V, R, and this is G for the galvanometer. You will get some current I. V by R plus G. Then you take a shunt resistance and keep it in parallel to the galvanometer. The shunt resistance ka value you can keep adjusting. So your job, you keep on adjusting the value till the current in the galvanometer becomes half. That's why it's called an half deflection method. They can also play like this, 1/3 deflection method, means current becomes 1/3. Right? And then when you try to solve, you will get an answer like this. So galvanometer resistance will be R into S by R minus S. So this is the result you should remember, where R is the resistance of this thing which is in series and S is the shunt resistance. So you can actually solve just like thing and you can get it. So this current will be I dash and you can do that calculations. So they'll give you some numbers, you will put it. So exam may they'll ask you like this. They will say in half deflection method, they will say R is equal to 10 ohms and the shunt resistance is equal to 2 ohms. Find the galvanometric resistance. 10 into 2 by 10 minus 2. So that's 20 by 8. Done. Straightforward equation. But the moment you hear half deflection method, you have no idea what to do. And even if you try to derive this formula, that will eat away at least 3 minutes. You know the formula, better. You can do it fast, then it is fine. If you can do it in less than a minute, then fine, derive. That's up to you. Let's get this. So remember the half deflection method. Displacement current comes in EM waves, modified Ampere's law. B you can do. C, yeah, they're fine. Get them all. I'll give 2-3 minutes, then I'll explain your stuff. So in case you don't remember what is the conduction current, the experiment goes like this. Ampere, when he derived the thing, so this capacitance is C. So integral B dot dl is equal to mu naught I. So when Ampere derived this equation, people didn't know that a changing electric field can create a magnetic field. So this is their I crossing. But later on, people realized even if you have a time varying magnetic field, electric field that can create a magnetic field, so the equation was becoming wrong. In order to do that correction, they introduced a pseudo current. So this is a false current, doesn't exist. It's only a mathematical correction, which takes care of. So the magnetic field B bar is due to the current wires that will I crossing will take care. Plus B bar due to time varying electric field. So if you are sure there are no electric fields changing with time, you can just use mu naught I crossing, time varying E bar. So the I displacement current is given by epsilon d electric flux by dt. Flux is nothing but dq by dt 1 by epsilon, which actually becomes dq by dt. And most of the time, simply I displacement is always equal to I conduction current. dq by dt is nothing but the current in the wire. So if this is a capacitance, this is charge q, this is minus q, you can write q is equal to cv naught sine omega t. The current I will be cv naught omega cos omega t. This is your peak value, that is your displacement current. So the concept was this: the current which is crossing here, this is called conduction current. This is also conduction current. So here I displacement is 0, but there's a conduction current. Between the plates, in reality, there's no current. So I conduction is 0, but there's an I displacement current. So the system behaves as if somehow the current is passing between the plates as if there is a wire. That's why we call it a pseudo current. You cannot measure it with an ammeter, but mathematically it works. So now if you look at the question there, first of all, they should be equal. So first option and the fourth option, they are the only two things which are there. Now you just need to figure it out. So there, so I current will be CV naught omega cos omega t. He's asking for RMS value, be careful. So RMS value will be CV naught omega by root 2. But actually this 230 is also RMS only. So you're kind of safe actually. VRMS omega C. You can actually do from AC circuit, isn't it? VRMS by Z impedance will give you the current. That only is asking. What about the second thing? Plane electromagnetic wave of frequency 35 megahertz travels in a space, blah, blah, blah. The magnitude of magnetic point is nothing. E by B is equal to C. And E cross B is equal to the direction of the wave, which is I cap. Check out these two and you'll get it. What about the third thing? Same story. Cos omega t minus Z. So this should be cos, cos, cos. So these two are gone because it is cos omega t plus Z. And then B will be E naught by C. Only one option is there. Clear? Easy question. So you just keep eliminating them and finish it off. What about this thing? The total average density. Now, if you guys remember, half epsilon E naught square sine square kx minus omega t. This is the energy density of a electric field. This is your U electric field. If you take U electric field ka average, the sine square becomes half. So this becomes 1 by 4 epsilon E naught square. Similarly, the magnetic field ka average energy is also 1 by 4 mu naught B naught square. And interestingly, the electric field and the magnetic field both contribute equal amount of energy. So U total will be, when you add them, you get half epsilon E naught square, or you can also use 1 by 2 mu naught B naught square. Both are right. So when an electromagnetic wave, electric field and magnetic field, they contribute equal amounts of energy. Clear? This is your energy density ka formula. Half epsilon E square yaad hai na? E becomes E naught sine kx minus omega t. So when that is your electric energy density as function of time t. The average will become 1/4. So electric field and magnetic field both will contribute 1/4 of the thing. So when you add them, you'll get half epsilon E naught square. So substitute there, you'll get it. What about this thing? So this you can figure it out. Infrared will be what? They'll have high wavelength. Ultraviolet rays, I think this one, no? B3, ultraviolet should be less than 400 angstroms. X-rays will be less than 100 angstroms. So how much is that? You can check it out. Is 4 answer? No? 5 ka 2 kya? Less than 10 power minus 3 nanometer. Oh shit, no, that is gamma, I guess. Yeah, that is gamma. D4, C3, I think 2 only. Yeah. A3, 1 mm to 700 nanometers. 700 nanometers, 7,000 angstroms. Yeah, that is exceeding close to red. Clear with that? So have a rough idea about the wavelengths. X-rays are, something like 1.1 to 100 angstroms is X-rays. Below X-ray is the gamma, right? 4,000 to 7,000 angstroms is visible. Above that is infra, and below that is X-ray, ultraviolet. This is a good one. See, this is the trap thing I was saying. So what is the catch again? Just now we saw theta by I is equal to NAB by K. So this is proportional to N. Great. Theta by voltage will be NAB by KR. Now here this is actually proportional to N by R. Now normally what used to happen, if you just change the number of turns, R would have changed. But in the question it is specifically mentioned the R remains constant. Somehow they messed up the area of cross section. They maintained R. So this is proportional to N since R is constant. Therefore, this also will change by 25%. So in the question, if they had mentioned this is achieved by changing the number of turns, that's it, right? Then, and look at the problem here. The word was this: the number of turns and the area of cross section of the wire while keeping the resistance of the galvanometer constant. That means they actually changed the size of the wire. In the first case, they used a thick wire. In the second case, they used a thin wire. Got it? So if you kept the thickness of the wire same, and if you increase the number of turns, the length of the wire would have increased. And because the length increased, the number of turns, the distance would have changed. So when you increase the number of turns, length changed, but they also messed up the area to keep the resistance constant. I hope you're getting the difference there. So be careful with that because you just remember the statement, voltage sensitivity won't change and zero भी है option में डाल देंगे directly without thinking. So theta by V is actually proportional to N by R. R is not changing, so this becomes proportional to N. Clear with this? So be careful with this. This is the trap that I was talking about. Easy one. Get this polarization again. So there are three polarites. The first one and the last one are perpendicular. The middle one is something like this. So this angle will be theta. You're sending unpolarized light. I. So this will come out like this. I by 2. Then this will come out like this. I by 2 cos square theta. Now be careful. Theta is the angle between the electric field and the axis of rotation. So now when this is coming out like this angle is 90 minus theta. So this will be I by 2 cos square theta ka cos square 90 minus theta. Are you clear with that? So this is I by 2 cos square theta sine square theta, which you can make sine 2 theta. And he's saying this is a 3 and that I is 32. So that is 16. Sine to theta ka square by 4 is equal to 3 by 16. 4 za 3 by 5. Sine to theta is root 3 by 2. Theta is 30 degrees. Clear with this? In the medium, the speed of the light wave decreases to 0.2 times its speed in free space. The ratio of the relative permittivity EM waves again. There is a direct result if you remember. थर्टी और 60 वो भी सही है. Sin to theta could be 60 or 120. Both are right. But did they ask any smaller angle? No, he didn't say anything. Do you guys remember the formula for this? Refractive index mu is equal to mu relative epsilon relative. This is the refractive index. Mu r is your relative magnetic permeability. Epsilon r is your dielectric constant or electric permittivity. So he's saying the ratio of relative permittivity to the refractive index of the medium is x is to 1. This is permittivity, yeah. So permittivity is your epsilon r. Permeability is mu r. And refractive index mu is nothing but speed of light in vacuum by speed of light in medium. So he's saying the speed of light became 0.2 times. So that's 1 by 0.2 or 5. So 5 is equal to root over mu epsilon r and epsilon r. Mu r is 1, so epsilon r will be 25. Then he's asking the ratio of x is to 1. So that is 25 is to 5. 5. Clear with this? Take a break. Come back in 5 minutes. We'll continue from here. Chalo, let's get them. Campfire everyone. 7 people ran away so far. How do we do this? So every time logic gates won't be like straightforward, they'll give you a gate. This is 166, huh? Yeah, I think this is something else. No, this is another question actually. This is the input, and it is the same thing. This is the input, and this is the output for this circuit. Let's see. So how do you handle this thing? Now see, when you close the switch, So when it is glowing, it is on. Why are these dots given here? Does it mean when you close it is 0? Okay, let's go from the picture only. So the picture is saying when you close this, it is 0. When you keep it open, it is 1. Right? At least that's what I can see from the picture there. Now, if you want the bulb to glow, right, both the switches must be closed. So that means when both are 0, 0. So here, when the switch is closed, it is 0. When it is open, it is 1. I think that's what I'm assuming with the zeros and 1. So perfect. So you want the switch to glow. One thing is clear. When A, B, when you close both of them 0, 0, then the bulb will glow. Even if one of them is open, 0, 1, 1, 0, 1, 1, the bulb will not glow. This is a NAND gate. B option. Getting it? So be careful with that. The zeros and ones are written here. If they don't write anything, then we will assume generally when you close it, it is 1. When you open it is 0. Then I think it would be in reverse of this. You would have got an AND gate. Yeah. So be careful with that. Ones and zeros are clearly written there. So we have to be careful. What about this 166? First, let's get the output of this. If you're sending A and A, that becomes A bar. B and B, that becomes B bar. And now you're sending to this. So A bar dot B bar ka whole bar. That would be A bar bar plus B bar bar, which is A plus B. This is an OR gate. Now, if you look at the inputs here, 0, 1, 1, 0, 0, 0, 1, 1. So first one should be 0. This guy is gone, this guy is gone. Second thing must be 1, so D is gone. So fourth option. Clear with this? Another question here. Now here, see. When you close it is 1, when you open it is 0. So be careful with that zeros and ones on top of that switch which is written. What kind of gate is this? So if the bulb glows, it is on. If the bulb is off, it is 0. So look at this thing. If I close any one switch, the current from here, actually, if you keep the switch open, current will flow like this. The moment you close any one switch, it will get shorted. Current will directly go through this. So if you close any one switch, the bulb will not glow. So if this switch was closed, this will get shorted. That means if in any one switch is, so here 0 is open, 1 is closed. So you want both of them to be open, 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 the bulb will glow. Even if you close one of them, 0, 1, it will not work. Again, this also become an AND gate. Clear with this? Because if you close the switch, the circuit will get shorted. There is no voltage across the bulb. The bulb will not glow. Clear with this? So be careful with that. Check the circuit whether the bulb will glow or not. So don't randomly assume like the bulb will glow every time. This is also an AND gate. This actually would have been something else, but because they did two things. They made this 0 and 1 reverse. This was series that became parallel. So there were two changes. So suddenly it became again an AND gate. Or else you would have got something else, maybe an AND gate. Moving call galvanometer. You know the formula now. What is the formula? It would be NOR gate, kya? that, nahi? 0, 0, 1. Even if 1 is on, it doesn't work. NAND, right? NAND nahi hai? Wait, I'm confusing myself, I guess. If it is an AND, there would be 0, 0, 0, 1. Opposite would have been 1, 1. Yeah, sorry. OR gate would have been 0, 1, 1, 1. Sorry, this is an OR gate. There I would have got a -1 for being in a hurry. Next thing. That was an OR gate. What is the formula here? अभी किया था हमने. Theta by voltage is equal to NAB by KR. This was the formula. NAB by KR. Substitute there, you are done. You'll get the answer. But for that, you need to know the formula. The light wave is propagating with the plane wave in the constant x plus y plus z is equal to constant. The angle made by the direction of the wave propagation with the x-axis. Vectors ना याद है? I plus j plus k. Cosine angles. Alpha, beta, gamma. The angle made by the vector with respect to x-axis. It's like I plus j plus k type, something of this sort. So you're finding angle between this and x-axis. Angle between this and I cap. These are also called as direction cosines. What about the next thing? Thin prism P1 4 degree. Same question which you have done before. But in this case, it's asking angle of the prism. So deviation delta plus delta dash must be 0. A into mu minus 1 plus A dash into mu dash minus 1 is equal to 0. This is 4 degrees. 1.54 minus 1 is equal to minus A dash 1.72 minus 1. You will get A dash is equal to negative something. The negative sign indicates the prism is inverted. So just be careful with that. Semiconductors. Let's read the statements. Consider an n-type semiconductor. So in an n-type semiconductor, electrons are the majority charge carriers, holes are minority. True. The dopant is a pentavalent atom. True. You need excess electrons. Ne is NH. This is wrong. This is always true. Ne into NH is always equal to Ni square. This is called law of mass action. This Ni depends on temperature. This is actually given by A T power 3 by 2 into E power minus delta Eg by some KT. ऐसा कुछ आएगा. No need to remember the formula. Just remember Ni increases with temperature. And this is the reason why resistance of semiconductors will decrease when you increase the temperature, whereas for conductors, resistance increases. Resistance of semiconductors decrease when you increase temperature. NeNH is greater than equal to Ni square. That is also wrong. The holes are not generated due to donor. True. Holes are generated. The donor is giving extra electrons, not the hole. So A, B, E, third option. Clear? So you should just know your statements, what each thing means. Like, meaning if you know your theory, it is not difficult. Bar magnetism. Two small magnetic dipoles each have magnetic moment 1 ampere meter square are placed along O and P. The distance between them is 1 meter. The torque experienced by one dipole due to the other. You should know the magnetic field due to magnets. It's completely fine if you are, forgetting and if you don't remember most of the things. I'm just trying to remind you how much you don't remember. So treat it like that, and you should revise this next 2-3 days. May finish it off, because I think after next week you should, you will not have time much. You have to focus on your chemistry, organic, inorganic, and all that stuff. Last 10 days, your job is that only to revise whatever things which you have to remember and all. So the organic, inorganic, it will eat away a lot of time. Abhi physics ka, these are the kind of questions and theory parts which you should see. And don't do anything new. Just focus on what you have done already, resolve the papers, whatever mistakes you did, all that stuff. That only have to keep repeating. Repetition is the key. So how to do this thing? First of all, you should know the formulas there. If you take a magnet, north, south, along the axial line, the field is given by mu naught by 4 pi 2 times m by r cube. On the equatorial line, the field is given by mu naught by 4 pi m by r cube. This is the magnetic field. And what is torque given by? Torque is equal to m cross b. Potential energy is given by minus m bar dot b bar. If you remember, these are the formulas, identical to electrostatics. If you guys remember electrostatics, Q is similar to pole strength. You should check out the notes. We wrote something called magnetostatics. Dipole moment P bar is equal to capital M, which is a small m into 2L. This is Q into D. Right? Electric field, here it is magnetic field. Electric field is K Q by R square. Here magnetic field K का place में mu naught by 4 pi, Q का place में small m by R square. यहाँ पे torque is P cross E. यहाँ पे torque is M cross B. So they would kind of give you all the same formulas there. Now once you know that, you are kind of done there. This is M1. This is M2. I wrote reverse. So M1, so for this thing, this is a equatorial line. So this is mu naught by 4 pi M1 by R square. And here the magnetic moment is M2 bar is in this direction, both are 90. So torque is equal to M2 into mu naught M1 by 4 pi R square. The mu naught M1 M2 by 4 pi R square. You know the values. M is given as 1 and R is equal to 1, and mu naught is 4 pi into 10 power minus 7. Substitute, you'll get the answer. Clear with this? EM waves. A plane EM wave is propagating in the x direction. Wavelength is 4 mm. Electric field is in y direction. Maximum magnitude is 60 volt per meter. Using this data, get the magnetic field. These kind of questions, mostly it is elimination. Instead of actually trying to eliminate the options. So first thing, again, E cross B is equal to, it is propagating next direction, I cap. Electric field is in Y direction. So this is J cross B bar is equal to I cap. So B bar must be along K cap. So K cap, so yeah, this is gone, but remaining three are there. Then we know B is equal to E by C. That is 60 by 3 into 10 power 8. That is 2 into 10 power minus 7. So this guy is gone. This guy is gone. We're left with these two. And then we have to use that wavelength there. They look same, kya? No. There's a 10 power 3 sitting here. So look at that wave here. So wavelength is given. So K is equal to 2 pi by lambda, which is 2 pi. Lambda is 4 mm. So that is 10 power 3 will go up. That is pi by 2 into 10 power 3. B option. Clear with this? So we have to check. So this is your kx minus omega t if you remember the equation. So it should be in the form of sine kx minus omega t. So k is that one, the coefficient. This is a good one, right? This will make things, a lot of things clear. Let's see how we'll do this. A deviation of 2 degrees is produced in a yellow ray when the prism of crown and flint glass are achromatically combined. This word is important. Achromatically, meaning what? There is no dispersion. Basically, if you send a white light, you'll get the white light out. The light rays won't disperse. No dispersion. That is the meaning of achromatic combination. Taking dispersive power of crown and flint glass, the dispersive power is that one, omega ka symbol. Think for a minute. Not tough, but kind of neglected thing, because the questions are also a little rare on this. They really don't ask too many of them, but they do come once in a while. Again, just to give you the formulas again. Deviation ka formula was A into mu minus 1. So a deviation of 2 degrees is produced. So A into mu LO minus 1 plus A dash into mu LO dash minus 1. This was 2 degrees. That's your first information. Dispersive powers are given. What is dispersive power? A into second thing, achromatically combined. Achromatic combination meaning this is delta plus delta dash. That's your deviation. Theta plus theta dash. This is your dispersive angle. This must be 0. So whatever angle that disperses, this will compress it again. This is the meaning of achromatic combination. But what is theta? Theta is the angle A into mu violet minus mu red. Theta dash is A dash into mu violet dash minus mu red dash, because refracting index will change. This is 0. That's the second equation. What is dispersive power? Omega 1 will be A mu violet minus mu red by mu yellow minus 1. So actually from here you'll get mu violet minus mu red, which is omega 1 into mu yellow minus 1. And omega 2 is mu violet dash minus mu red dash by mu yellow dash minus 1. So this will give you mu violet dash minus mu r dash is equal to omega 2 mu y dash minus 1. Now if you take and dump it there, you'll end up with a omega 1 mu yellow minus 1 plus a dash omega 2 mu yellow dash minus 1 is equal to 0. You know omega 1, omega 2, you know mu yellow and mu yellow dash. From there you'll get a and a dash ka value. Take that and substitute here. That will give you the refractor angle of the ground glass. That's a lot of work actually. So if I take this values again here, A ka value we don't know. Omega 1 is 0.02, mu yellow minus 1 is 1.5 minus 1 plus A dash also I don't know. 0.03, 1.6 minus 1 is equal to 0. This will give you one relation. This is 2, that is minus A dash 3. 0.6, so 1.8. That's one relation. And from here we will get a mu yellow minus 1 is again 0.5 plus a dash is mu dash minus 1 is 0.6 is 2. You want the refractor angle for the crown prism. That is your A. So replace A dash here. So this is half A. This is A by 3 is equal to 2 dash. This is A by 6 is equal to 2 degrees. A is equal to 12. Quite long. So main thing are these three formulas. So this guy, and these two. Dump it there and solve. I literally taught you the whole concept. Matlab, I don't think they can ask you more than this in this kind of questions. If you got this question, how to do, you can handle all these kind of questions. Little rare, comes a little rare, but there's the concept there, just in case. Get them, these are repetitive only again. 1, 2, 3. 3 questions are there. Displacement current, energy content in the field, dielectric constant of the medium. Get them, I'll give you a minute. Then I'll just show you. At least get the main formula and leave it. It's fine if you can't simplify. But now you got the idea, like, I was teaching you whatever I can with that little. So the parts which you need more data, you should go back to the notes and check it out. I'm just trying to brush up as much as I can. So because it feels really bad, huh? Matlab, exam you come and then you will see the question was so easy just because you didn't remember a formula. Let's see the formula again. What is the displacement current? You can literally actually use, this AC circuits and finish it off this. So Q is equal to CV. C is equal to A epsilon by D, right? And Q is equal to CV, that is the 20 sine omega t. I is equal to dq by dt. And done. That's your displacement current. What is energy contained in the cylinder per centimeter cube? So basically energy density. Remember, this thing contains both electric and magnetic field. He didn't specify anything. He said energy, so it is total. Energy density is energy by volume. Is half epsilon E naught square. E naught is 50. Epsilon is given, dump everything, and you'll get the volume from there. What about this thing? Electric field, non-magnetic medium. So non-magnetic medium implies mu r is equal to 1, mu relative, which is the relative permeability. And then look at the speed here. Huh? We know the wave speed, V wave, is nothing but omega by k. So here omega is 2 into 10 power 10 and k is 200. That is 10 power 8. That means the refractive index of the medium is C vacuum by C medium, which is 3 into 10 power 8 by 10 power 8. So indirectly, they're giving a refractive index with speeds. Then we know the formula mu is equal to root over mu relative into epsilon relative dielectric constant. 3 is equal to root epsilon r is equal to 9. Clear with this? How to get the refractive index from the equation? So you have to find the speed of the wave, which is not 3 into 10 power 8. So it is in a medium basically. All got this? I hope you're seeing right how we are digging out data from the equation. So that is how it is. So the wave equation will tell you everything there, the speed and everything. Non-magnetic medium matlab mu r is equal to 1. Do you guys remember that result for diamagnetic? What is mu r? Less than 1. It is repulsive in nature. Let's get these two. And these are easy ones, but let's see. So what are you giving exactly? You're giving A and you're giving B bar. So this would be A plus B bar. Then you kept a NOT gate. So you're giving A plus B bar ka whole bar. So when you simplify this, this will become A bar dot B bar bar, which is A bar dot B. Means I need an AND gate where for A ke liye I need to give a NOT gate, and this is how it should look. Or you kept a circle in front of it. So that means I can mess it up again. I have to go through the options, I guess. I can check actually. This is A, this is B bar. So there's a circle here, there's an AND gate. So this is A dot B bar ka whole bar. That won't work. I think B will work, I guess. I'm not sure. So this is A bar, this is B, this is A bar, D at B ka whole bar. I think 3 only will work maybe. No, 3 is something else. Hey, D option is there na so clearly. I'm blind. There. Happens. Then what was the second thing? This is 10 volt, this is 5 volt. If this is 5, this is also 5. If this is 5, this is also 5. Agreed? Because total is 10. So if that is 5, then this current will be 5 by 1 kilo ohm, 5, that is 5 milliampere. This will be 5 by 2, that will be 2.5 milliampere. So the question is, where is the remaining current going? 2.5 milliampere here. So that is 25. Clear with that? You cannot find the current in the diode directly. You have to find the current in the nearby branches and then figure it out. Clear? The semiconductor, the number density of intrinsic charge carriers is 1.5 into 10 power 16. Semiconductor is doped with the impurity atom, the hole density. Find the electron density. Easy. But if you know what they're actually talking about. Most people, they'll read this, they're like number density, doping, semiconductor, impurity, hole density, gone. Fuse there, only it blows off. What are they talking about? Intrinsic charge carriers. This is Ni, 1.5 into 10 power 16. This is the hole density. This is NH, 4.5 into 10 power 22. NH into Ne is equal to Ni square. Law of mass action. Solve, you'll get the answer. बस इतना ही करना था. Vernier calipers. There's nothing to solve. First question, there's nothing to solve. Look at the readings here. 5.50, 5.55, 5.45, 5.65. How many decimals are there? 2. Your final result cannot be more accurate than this. Right? C option. Got this. You cannot have your final answer more accurate than your initial readings. So you should have only 2 decimals. C is the only option, 2 decimals, you are done. ये बाकी ये सब ना, it is just distraction. Clear? Remember that. So if you look at the readings, 5.50, 5.55, 5.45, 5.65, all have only 2 decimals. So the final result, whatever is it, should also have 2 decimals. Or you can say they should have same number of SF. Actually, in this case, should have same, because when you add them, right, should have same accuracy. And get the next one. That is Vernier calipers. The least count of the main scale of a Vernier caliper is 1 mm. Vernier scale is divided into 10 divisions. So standard one, that is. When jaws are touching each other, the 7th division of Vernier scale coincides with the main scale. And the zero error of the Vernier scale is lying to the right side. So 0 is lying to the right side. So it's a positive error. How much? 7 LC. Therefore, correction is minus 7 least counts. Now, when this is used to measure the length of a cylinder, the vernier is between 3.1 and 3.2. So that is 3.1 centimeter plus 4 vernier scale divisions, the 4 LC. Correction is minus 7 LC. That's 3.10 centimeters minus 3 LC. That is 0.01 centimeter. So 3.07 centimeter. Clear with that? So that you have to visualize the whole picture. They won't give you the picture every time for 1 year calipers. So even when there's no object inside, it is measuring 7 least counts. Matlab, final correction, you have to subtract 7 least counts or minus 7.7 mm. One least count is 0.1 mm. Got this. That's a bit about 1 year calipers. This is another good one, right? EM waves. There are two electric fields. There's a particle charge q at the origin with a velocity. Find the instantaneous force experienced by the particle. Let's get this. So how do we do this? First, you need to find, look at that thing. The first electric field, right, is E naught J cap. So let's substitute the values, okay? It's at T0, X0. So E1 bar at this instant will be E naught J cap. So this will produce a magnetic field, B1, which is E naught by C. And what will be the direction? E1 cross B bar must be I cap. So that is J cross K. So this is K cap. Similarly, E2 bar will be E naught K cap. This will give another magnetic field, which is E naught by C. And again, E2 cross B must be J cap, and E2 is K cap. So this would be K I J K. So K cross I. So this is I cap. So the total electric field is given by E naught J cap plus K cap. The total magnetic field is given by E naught by C I cap plus K cap. And we know the force is equal to Q E bar plus Q V cross B bar. Lorentz force. Substitute there, will get the answer. Clear? Because it's at T0, X0 I just substituted there and I got the electric fields. From there I can figure out everything I want. So the main idea is that most people, they'll just find the electric field ka force. You need to understand that two electric fields will create two magnetic fields. So then you get the entire Lorentz force. And you need not find the exact equation. We don't care because he's just asking the instantaneous force. So just substitute T0, X0, make your life easy and finish it off. If they ask you as function of time t, you can still figure it out. Not a big deal, but yeah. There is one more type of question. Let's say the electric field E bar is given by E naught sine kx sine omega t. Can you find V bar? Now remember, this is not a progressive wave. This is a stationary wave. So here you can't say E and B will be in phase. You have to use some different formula here if you remember. In case you forgot, this is the formula. Dou E by dou X is equal to minus dou B by dou T. This is the formula which you have to use. This you should know. Not there in NCERT also, but this was asked in one of the JEE exam. So you need to know this relation. Dou is the partial differentiation. So first differentiate. Dou E by dou X will be E naught K cos kx sin omega t. You're saying this is dou B by dou T integrate. So B is equal to minus E naught K cos kx integral sin omega t dt. That would be minus E naught by K by omega cos kx minus goes off cos omega t. Sin becomes cos. So be careful. If it is a progressive wave, that would look like sin kx minus omega t. So magnetic field also must be kx minus omega t. But these are stationary waves. So this is a good one. Huh? This is a little out of the standard one. So when the inputs are 1 0 0 0 1 1 0 1, can I simplify this? This is A, this is B, this is A dot B ka whole bar, this is A plus B. Shit, right? This is so messed up. This is A dot B whole bar ka dot A plus B, and then these two are given. And I just put some option and finish it off here. I think we can take any two values. Now, if we take 1 0, this is 1 0, 1 0 will get eliminated. Then we have to check one more. So let's put 1 0. So this is 1 and 0. The 1 0, that would be 0, that would be 1. This is 0 1, that will be 1. So if you're giving 1 and 1, you will get 1. And if you're giving 1 1, this would be 0. So either B or C. Then let's put 0 0, or let's put 0 1. With this and this, now we have to be smart on how to put the options. Huh? Because this guy is 0, this guy is 1. So that will work. Don't take the 0 1, because 0 0 both are same anyways. So I think the best thing to take is the next one only, 0 0. So if you take 0 0, that would be 0, that would be 1 0 0 0. 1 0 0 and 1 0 will be 1, and that would be 0. C option. I think this is faster. Let's see how it works for you. Clear with this. Another important one, vibrational magnetometer. फॉर्मूला याद है? टाइम पीरियड इज 2 pi root over moment of inertia I by mb. Quite important. मतलब magnetism में every year whenever they ask, this is one of the question which keeps popping up. This is your moment of inertia. M is your magnetic moment and B is your magnetic field. Technically, this is BH actually. So the length of a bar magnet is large compared to the width and breadth. Okay. The time period of the oscillation means you can take it like a rod. Time period of oscillation is 2 seconds. The magnet is cut along its length into 3 equal parts, and these parts are then placed on top of each other. So you did actually multiple things. This was moment of inertia M, and this is a magnetic moment M and I. When you cut them into 3 pieces, the magnetic moment becomes M by 3, M by 3, and M by 3. So technically, magnetic moment didn't change, but you messed up the moment of inertia. What happens to the moment of inertia? We know moment of inertia I is proportional to ml square. Mass is proportional to L, so this is proportional to L cube. So when the length becomes 1/3, the moment of inertia becomes I by 27, I by 27, I by 27. So for the new system, it behaves like a magnet. Magnetic moment is M, but the moment of inertia is I by 9. Clear with the difference? Magnetic moment didn't change, moment of inertia changed. Got this? So therefore, the time period is proportional to root over I. That becomes 1/9. So 1 by 3, 2 by 3 seconds. Are you clear what happened here? So when you cut the magnet, it became M by 3. But when you placed on top of each other, it became again M only. So you actually made the rod, compressed it to 1/3 of the length. Mass remained same. L became 1/3. The moment of inertia got messed up. Are you clear with this? Clear? So that's a bit about today. So when we catch up on Monday, we'll continue from here. We'll have a few more. We will do them. And then on Monday, we'll have a speed test. I think 6 o'clock, we will start the class on Monday as usual. Mostly, I think by 7, 7:15, we should finish it off. And then Monday, we have a big speed test. We have 200 questions, 1.5 hours. That will be a big one. So make sure to give it. So if you start that at around 7:15 or something, we will wrap up by 9. Then I'll give you a break. And 9:30, we have the meeting. And next Wednesday, we'll have one more speed test. And that would be the last session. With that, we'll wrap it up. And next Wednesday, the session will be on these topics. Semiconductors, bar magnets. So I want you to have 3-4 days time to revise all this stuff. So Wednesday, we'll have a paper only on these topics only. So Wednesday will be the last session, right? So after that, you got 1 week time for the exam. So it's about time you can start, revising and all that stuff. Okay, we'll catch up on Monday at 6 o'clock. We'll continue from here. So there, I think we did around 30-35 questions today. So you can go through them. I did try to cover different stuff. We have few more, another 10-12 models more. I'll show you in the next class. Okay, with that, we'll wrap up for the day. So any doubts, anything else, please stay back, or else I'll see you on Monday at 6 o'clock. So take care, stay safe.